Good day. Eigenvalue problem in finite element analysis. Today I discuss the topic about eigenvalue problem. So, what is eigenvalue? Eigenvalues are the set of scalar values that is related with the set of linear equations most probability in the matrix equations. Here I have another doubt, which is what is meant by scalar values. For example, if we consider the height of the human, which may be 6 feet or the thing around 300 centimeters. Likewise, we are having the values which are all considered scalar value because height has only one dimension, which is mm or length. Okay, so that these are all the quantities are known as scalar value. In engineering, lot of scalar values available. That scalar values can be solved by eigenvalue problems. Here the equation, the a11 y1 plus a12 y2 plus up to plus a1n yn is equal to 0. What is the name of this equation, which is the linear equation? So from this linear equation there are eigenvalue and eigenvector available. Here which one is eigenvalue, which one is eigenvector? Here the equation has a11, a12, a1n. Likewise the value has. So what is the name of these a variables which are known as eigenvalues? After that, the same equation has as like y1, y2, yn. Likewise other contents are also available, other variables also available. These variables are known as eigenvectors. Here how can we convert these forms into matrix form, which is the initial thing that is available with the finite element analysis, so that I can collect eigenvalues from this equation as like a11, a12, a11 from this equation, and then a21, a22 and a2n. Likewise I can collect the values from this available equations. From this I can form the matrix, okay, which I consider 3 cross 3 matrix, so that I can consider a11, a12, a13. I can collect these values from the first equation. After that a21, a22, a23. Likewise I can also collect the values from the second equation. If I consider the third equation, means a31, a32, a33. Likewise I can collect. From this I can frame the 3 cross 3 matrix. After that I can collect other values that are available with the equation, which are y1, y2, y3 also. The y1, y2, y3, which is known as eigenvectors. So the lambda can be represented for a11, a12, a13 to a33, which is 3 cross 3 matrix, and also I can represent the matrix with the eigenvectors, which is y1, y2, y3 as like a dependent variable which are available with our equation. After that I have another question. The question is, what is eigenvalue and what is meant by eigenfunctions? Values of non-trivial solution available with variables called eigenvalues and corresponding non-trivial solution called eigenfunctions. So I can explain what is trivial solution. So every mathematician should aware about what is trivial solution and what is non-trivial solution. For understanding the trivial solution, I can explain the equation, which is x plus 5y is equal to 0, as the trivial solution with the 0, 0. Non-trivial solutions include 5, minus 1 and minus 2, 0.4. From this, how can we represent the equation as like a trivial solution equation and a non-trivial solution equation? Yes, I can explain with example here. X plus 5y is equal to 0. I substitute for x as 0 and y as 0, so that the expression may come under 0 is equal to 0. Likewise the conditions are satisfied with the left hand side to right hand side. So I substituted the variables x and y 0. The solution also satisfied with 0 is equal to 0, so that the solution is called as trivial solution. And what is meant by non-trivial solution? Rather than 0, 0 for x and y, I can substitute x equal to 5 and y is equal to minus 1. in the specified equation of x plus 5y is equal to 0. Here 5 plus 5 into minus 1 is equal to 5 minus 5 is equal to 0. Here also I may get 0. So that these kind of equations are known as non-trivial solution. And then x equal to minus 2 and y equal to 0.4. Likewise I can enter on the same equation, which is x plus 5y is equal to 0. From this minus 2 plus 5 into 0.4. Likewise I may get the equation from this. Minus 2 plus 2 is equal to 0. Likewise I can get the 0 from the available equation, which is also known as non-trivial solution. Now you may aware about what is meant by trivial solution and what is meant by non-trivial solution. So Eigen problem is always deals with non-trivial solution problem. So we can't deal with x equal to 0 and y equal to 0 with the eigenvalue problem, but we can assign some more values on that equation for getting the 0 with the prescribed equations, as like this. Okay, so now I can start the explanation with some example problem. The problem is find the eigenvalue and eigenfunction of d square y by dx square minus 4 lambda into dy by dx into 4 lambda square y is equal to 0. The eigenvalue problem has boundary value also, so that with the boundary conditions of dy by dx of 1 is equal to 0 and another boundary condition is y of 2 plus 2 into dy by dx of 2 is equal to 0. Likewise I have the boundary equations or boundary conditions for the problem to identify the eigenvalue and the eigenfunction. Here the first step, the auxiliary equation framing is the first step in eigenvalue problem. So what is meant by auxiliary equation problem framing? We should aware in that the equation that is obtained from a given linear differential equation, as like our previous slide I told about what is a linear equation. Likewise the equation that is obtained from a given linear differential equation by replacing with 0 the term that involves only the independent variables. So convert the equation to substituting the 0 for independent variables, and also substitute the 0 for dependent variables, and also we can collect the independent variable in the equation also. For understanding this procedure I can explain with the problem. Here the auxiliary equation for considered d square y by dx square minus 4 lambda into dy by dx plus 4 lambda square y is equal to 0. In that I substitute for d square y by dx square with k, so that this term is converted into k square minus 4 lambda dy by dx in terms of I explain with k, so that 4 lambda k plus 4 lambda square. Likewise I can substitute the value here. I can leave the y as the dependent variable from the equation, so I eliminate the content from the available equation, so that I can get the auxiliary equation of k square minus 4 lambda k plus 4 lambda square is equal to 0. Not only the procedure is ended, so we can move to simplify the available auxiliary equation as like this equation it into another form. Here you see the equation may be looking like with the a minus b the whole square, because here you see k is means a and b is 2 lambda if I consider, means the equation may be converted it into a minus b square terms. Here you see k square minus 4 lambda k, which is equal to 2ab plus b square means 4 lambda, so 2 lambda is equal to 4 lambda square. Likewise we can convert, so that we can get k minus 2 lambda into k minus 2 lambda. Likewise we can collect the simplified form from the auxiliary equation, which is the initial step that is available with the eigenvalue problem. So you convert the available problem it into auxiliary equation formulation. After that you may simplify the equation, auxiliary equation it into simpler form. The next step, you can identify the variables which are k1 and k2, which is independent variables. K1 is equal to 2 lambda, k2 is also is equal to 2 lambda. According to our auxiliary equation formulation, we can get the values like that. After that, the next step, After framing the auxiliary equation, after finding the independent variable values, we can move to complementary function. So the complementary function, two real and equal roots. Here in auxiliary equation we can get the values as like k1 is equal to 2 lambda, k2 is equal to 2 lambda. So two real and equal roots are collected from the equation. So complementary general form can be written as like y of x is equal to c1 plus c2x into e power k1x, which is a generalized formula which is available with the complementary function. So if I got two equal roots means which is the general form, I can substitute the values. Okay, here you see c1 e power, what is the k1 value, which is 2 lambda. So c1 is into e power 2 lambda x. After that plus c2 x, here available x, so into e power 2 lambda x, because k2 also available, so that k2 is also 2 lambda, so that x into e power 2 lambda x. So the complementary function is looking like y of x is equal to c1 into e power 2 lambda x plus c2 into x into e power 2 lambda x. Likewise, we can get the complementary function equation of the available problem. After that, we are having two boundary conditions, so that we should differentiate the complementary function with respect to x, which is also one of the steps, because we are having two boundary conditions. So the differentiation, already we know about d by dx of x power n is equal to n into x power n minus 1, which is the general form. The same form I utilized here. So differentiate complementary function with respect to x. Y dash of x is equal to 2 lambda into e power 2 lambda x into c1. Likewise I got plus, here you see two terms available, plus c2 into x into 2 lambda e power 2 lambda x plus e power 2 lambda x, which is the formula for e power x into e power x, so that we can get the terms as like this is equal to 0. After that, what is the next step? After arriving the auxiliary function, after arriving the complementary function, we can move to applying the boundary condition of the respective complementary function. First, I consider first boundary condition, which is dy by dx of 1 is equal to 0. Here, the independent variable, which is x is equal to 1, and the dependent variable y is equal to 0 available. So I have to have substitute the collected value on the complementary function equation, which is 2 lambda c1 into e power 2 lambda x plus c2 into x into 2 lambda into e power 2 lambda x plus e power 2 lambda is equal to 0. What I got from previous step, which is differentiation with respect to x on complementary function, I may get this equation, so that I can substitute first boundary condition on that complementary function. From this, I can substitute 1 for x and 0 for y. What are all the x values available? Yes, 2 lambda c1 into e power 2 lambda x. For the x, I can substitute 1 plus c2 into x into 2 into lambda e power 2 lambda x. Again, I am substitute 1 plus e power 2 lambda is equal to 0. Likewise, we can substitute the x and y respective values on the corresponding places. From this, we can get the equations for y of 1 is equal to 2 lambda into c1 into e power 2 lambda plus c2 into 2 into lambda into e power 2 lambda plus e power 2 lambda is equal to 0. After that, for simplifying this equation, for arriving the next step, we can simplify this equation. For simplifying this, I can commonly take e power 2 lambda from the both the variable terms. So e power 2 lambda is equal to 0, which is not satisfied, so that I can remove the element from the available equation. After that, I can get 2 lambda c1 plus c2 into 2 lambda plus 1 is equal to 0, which is the simplified form of the first boundary condition application on complementary function. After that, the second boundary condition is y of 2 plus 2 into dy by dx into of 2 is equal to 0, which is the second boundary condition that is available with our problem. So I can substitute the same boundary condition with the available complementary function of y dash of x is equal to 2 lambda c1 into e power 2 lambda x plus c2 into x into 2 lambda into e power 2 lambda x plus e power 2 lambda x is equal to 0. From this I can substitute. Here the two terms are available. One is y of 2, another one is 2 into dy by dx of 2. Here y of 2 is equal to c1 into e power 4 lambda plus 2 into c2 into e power 4 lambda. Likewise I may get. After that y dash of 2, what is the value? Is 2 lambda into c1 e power 2 lambda into 2 plus I can substitute the x value with where I substituted, where I present the values with respect to x. Here I substitute 2 where the x value is available with the complementary function equation. Likewise, I can substitute 2 values with respect to the given equation. Here I substituted 2 only. Here also in differential equation also I can substitute the 2 values on the available functions. After that y dash of 2 is equal to 2 lambda c1 into e power 4 lambda plus c2 into 4 lambda e power 4 lambda plus e power 4 lambda I got. You can calculate with your notebook also. You can get the values as the same. Where the x values available, I can substitute the boundary values onto that corresponding area. I can get the finalized equation as like this. After that, what is the next step? Adding. I got the two boundary conditions substituted values. I got two complementary function with respect to the boundary conditions, so that adding I can simplify furthermore, so that I can add both the conditions, because in my boundary condition is known as y2 plus 2 into dy by dx of 2 is equal to 0, so that I can add both the things with each other. From this I can get the c1 into e power 4 lambda plus 2c2 e power 4 lambda plus 2 into 2 lambda c1 e power 4 lambda plus c2 into 4 lambda e power 4 lambda plus e power 4 lambda is equal to 0. After simplifying this, I can get c1 plus 2c2 plus 4 lambda c1 plus 8c2 lambda plus 2c2 is equal to 0. Why? I eliminate e power 4 lambda element from the above equation, because e power 4 lambda is common term that are available with the previous equation, but it does not is equal to 0, so that I eliminate that content. Now I may get the equation like this. After that I can simplify this equation into smaller form. Here I can collect the c1 terms with each other and the c2 terms with each other for considering c1. Here c1 plus 4 lambda into c1 available. If I simplify means I can take the c1 as the common term from this, so that 1 plus 4 lambda into c1 plus 8 lambda plus, here you see 2c2 available. If I add both the things, I got 4c2, so that 8 lambda plus 4c2 available. After that I can take the common term c2 from the both element, so that I can get this equation, which is 1 plus 4 lambda into c1 plus 8 lambda plus 4 into c2 is equal to 0. So now I can get the equation like this. How can we identify the c1 c2 value? For the reason, I may utilize determination of both boundary condition solutions. So how can we perform the determination with the matrix? Yes, I can collect the equation as 2 lambda c1 plus c2 into 2 lambda plus 1 is equal to 0, which is from the first boundary condition equation. After that 1 plus 4 lambda, which is arrived from the before the boundary condition application, 1 plus 4 lambda into c1 plus 8 lambda plus 4 into c2 is equal to 0. Here determination I can conducted through matrix operation. I can collect the c1 coefficient individually. Here c1 2 lambda, another equation's c1 coefficient is 1 plus 4 lambda. After that I may move to next column. Next column is c2 coefficient, which is 1 plus 2 lambda and then 4 plus 8 lambda. Likewise I can arrange. After that I can simplify. I already know about how can we perform the matrix operation. Here I can cross multiply the term 2 lambda into 4 plus 8 lambda and then minus 1 plus 2 lambda into 1 plus 4 lambda, and then I simplify the conditions 8 lambda into 1 plus 2 lambda, because here 4 plus 8 lambda available. In that I can pick 4 as the common term. So 4 into 2 lambda, which is equal to 8 lambda. Here 4 I removed means 1, and also I can place took the 4 from 8 means 8 divided by 4 is equal to 2. Likewise we can perform. After that the equation looking like 8 lambda into 1 plus 2 lambda minus 1 plus 2 lambda into 1 plus 4 lambda. After that we can simplify this equation again, because both the terms has the common term as like 1 plus 2 lambda. So that I commonly took 1 plus 2 lambda from the entire equation. From this 1 plus 2 lambda into 8 lambda minus 1 plus 4 lambda is equal to 0. After that I can furthermore simplify the equation 1 plus 2 lambda into 4 lambda minus 1. Here 8 lambda minus 1 plus 4 lambda available. 8 lambda minus 4 lambda is equal to 4 lambda minus 1. Likewise I can simplify this equation. I can equate it into 0. From this we can get 1 plus 2 lambda is equal to 0, which is the one form. Another one is 4 lambda minus 1 is equal to 0. So that 1 plus 2 lambda is equal to 0. From this I can get lambda 1 is equal to minus 1 by 2, because 1 plus 2 lambda is equal to 0. So that 2 lambda is equal to minus 1. After that lambda 1 is equal to minus 1 divided by 2. Likewise we can convert. After that the second term, which is 4 lambda minus 1 is equal to 0. Here if I equate the condition, I can get lambda 2 is equal to 1 by 4. Likewise we can get the eigenvalues from the available equation. After that, what is the step? The identification of eigenvalues. According to our previous step, lambda 1 is equal to minus 1 by 2, lambda 2 is equal to 1 by 4. Both are the eigenvalues. Then we can concentrate on complementary function, which is y of x is equal to c1 into e power 2 lambda x plus c2 into e power 2 lambda x for identifying the eigenfunctions. Here I can substitute the first condition. First always considered c1 is equal to 0 and lambda 1 is equal to minus 1 by 2. What I got from the eigenvalues from the before the step, I can substitute the same thing here. So y1 is equal to c1 is equal to 0 into e power 2 lambda x plus c2 into x into e power 2 lambda x. What can we perform with the lambda? You know, lambda 1 is equal to minus 1 by 2. For identifying the first function, we can substitute the lambda value as a minus 1 by 2. So from this, the first term is eliminated with a 0, because c1 is equal to 0. And the second term c2 into x into e power 2 lambda x is converted into the substitution of minus 1 by 2 with the lambda value. So that c2 into x into e power 2 into minus 1 by 2. If I remove 2 by 2 means I got minus x. So c2x into e power minus x I got. Then the second eigenfunctions. Here also c1 is equal to 0, because I have two boundary conditions. So two eigenfunctions are available with my equation. So that c1 again I substituted like c1 is equal to 0, lambda 2 is equal to, what is lambda 2? Yes, 1 by 4. I substituted the same value into the available complementary function equation, which is y of x is equal to c1 into e power 2 lambda x plus c2 into x into e power 2 lambda x. I replace the lambda 2 with the 1 by 4, so that the first term, which is c1 into e power 2 lambda x, it is 0, because c1 is equal to 0, plus c2 into x into e power 2 lambda is replaced with 1 by 4 into x. From this I can simplify. I can get c2 into x into e power x by 2. Likewise we can get the two eigenfunctions from the available problem. y1 is equal to c2 into x into e power minus x, y2 is equal to c2 into x into e power x by 2. Which are all the procedures we can follow to find out the eigenvalues and the eigenvectors. What is the application of eigenvalue problem? Yes, in practical applications also available. For example, if you are consider oil refinery on landfills, means we can utilize the bore wells. Here, oil companies frequently use eigenvalue analysis to explore land for oil. So, the exploration of oils from land, we can utilize the eigenvalue. Okay, what we are performed with the mathematical calculations, we can perform the same thing for oil value identification in the landfills. So oil, dirt and other substances all give rise to linear systems. So available of oil, dirt, these are all we can frame with the linear system equations which have different eigenvalues. So eigenvalue analysis can give you a good indication of where oil reserves are located. From eigenvalue problem, we can identify the location of oil within the land. Okay, so oil companies place probes around their site to pick up the waves that result from a huge truck used to vibrate the ground. The waves are changed as they pass through the different substances in the ground. The analysis of these waves directs oil companies to possible drilling sites. So the oil companies can identifying the oil drilling sites with the aid of these kind of eigenvalue problem, which is one kind of applications available with the eigenvalue problem.